extremely interesting lecture. You have pointed out very critical and important issues. So now, Professor Neri, the good news is the paper has just come up, I think today or the day, and it's published online and it's available on Insight. Published online and it's available on Insight in Imaging.
So, thank you, Valerie. You anticipated one of my slides. In fact, I was just mentioning that the paper has been today published in Insight into Imaging, our official journal. So, the learning objective of these lectures is to describe the construction of the ESR paper on artificial intelligence in radiology, to provide an overview of the paper, and to describe the strategic view of ESR on artificial intelligence radiology. This is the snapshot of the paper that you can, of course, upload from the Insight into Imaging website. The paper has been designed from dummies to dummies, because, of course, we are not experts, we just try to study and to allow the radiological community to better understand with simple concepts the meaning of artificial intelligence in radiology and its professional impact. So the paper has been prepared by myself. When I was in the position of chair of ESR, he held informatics subcommittee, by Professor Nadira de Souza, chair of the Highball, by Dr. Adrian Brady, chair of the ESR Quality, Safety and Standard Committee. Of course, we have to thank for their valuable contribution members of the eHealth Informatics Subcommittee as Dr. Bayarri, Professor Becker, Dr. Coppola, and Dr. Visser. And the paper, thanks to the Executive Council, has been approved in February 2019. The article was designed because the European Society of Radiology is aware of the impact that artificial intelligence is having in our discipline, from technical, scientific, from ethical, professional, and economic perspective. When the media started the discussion about artificial intelligence radiology, there were some interventions by eminent experts, we know, predicting the imminent extinctions of our specialty, who rose fear in the radiological community. These are the two main experts that they said. Andrew N.J. from Stanford, a computer scientist, he said, highly trained and specialized radiologists may now be in greater danger of being replaced by a machine that is its own executive assistant. It's a strong assumption. The other one, strongest, Geoffrey Hinton, has been mentioned for having won the Nobel Prize of Computer Scientists presently. If you work as a radiologist, you are like the coyote that's already over the edge of the cliff, but hasn't yet looked down, so doesn't realize there is no ground underneath him. People should stop training radiologists now. It's just completely obvious that within 5 years, deep learning is going to do better than radiologists. We've got plenty of radiologists already. So, as one of the responsibilities of ESR, Health Informatics Subcommittee, this paper aims to provide a review of the basis for application of AI in radiology, to discuss the immediate ethical and professional impact of AI in radiology, and to consider possible future evolution of such technology within diagnostic imaging. The paper is structured in introduction, definition, use cases, other application of AI in radiology, not considering only image interpretation, barriers to AI in radiology, and finally, the impact of AI in radiology. Training, which is an important aspect that we have to consider, should be also part of the discussion tomorrow, and the future direction. And of course, we tried to answer the question, the fatidic question that everyone asks, will radiologists be replaced by AI? An important section of the article is dedicated to the clarification of some terms and concepts necessary to better understand the principle of artificial intelligence and the neural networks that underlie them. So here you can see a list of terms that you have already heard, and we try to explain the terms in simple words. So I don't want to focus on that, of course, you already have heard about that. One important thing is that from a review of the literature that we made, during the drafting of the article, it emerged that the term artificial intelligence associated with the term radiology is constantly associated also with the term computer-aided diagnosis. So there is a lot of confusion between CAD and artificial intelligence, even if part of CAD is enforced by artificial intelligence. So from the graph emerged a peak of the publication relating to the last 10 years with a progressive foreseeable increase in 2009. So most of the publication in the last 10 years. From the analysis of the literature that we made, it emerged also that the main application of artificial intelligence in radiology concern image segmentation and interpretation, as we have seen in the previous sessions and the lectures. And among the articles are then predominant application in the field of neuro, chest, we have seen, abdomen, MSK, breast. So just repeating the previous sessions. But if the literature seems to be oriented toward application aimed at improving the diagnosis, this was an opinion of the working group. It was an opinion of the working group that the most imminent path of artificial intelligence radiology is actually in other fields, in the workflow, as we mentioned in the discussion before. Radiomics, imaging biobanks, dose optimization, structure reporting, appropriateness. These are the fields where most probably the first and immediate impact of AI will be perceivable from the radiological community. Radiomics is we have seen, the extractions of features from diagnostic images is the final product of which is a quantitative features, parameters, measurable and mineable from images. What we can expect from AI in this field? AI can foster the analysis, it's already doing that, of radiomics features and help in the correlation between the features and the omics. Think about that. It's a very important multidisciplinarity, proteomics, genomics, liquid biopsy, terms that we have already heard from the speakers, building the so-called patient signatures. So we all have signatures, and these signatures are the overall amount of omics data, not only radiomics. Another field in which there will be an impact of AI. In 2015, ESR set up a working group dedicated to imaging biobanks. Hans-Ulrich Kautzer was one of the managers of this. He was chair of the research committee of ESR. And we produced a position paper creating a memorandum of understanding with BBMRI, the organization that governs the European Biobank Network. Imaging biobanks, what are imaging biobanks? Imaging biobanks can be defined as organized database of medical images and associated imaging biomarkers. As Professor Bonmati mentioned, radiology and biohunt shared among multiple researchers and linked to other biorepositories. So what we have to expect from AI? Large biobanks have the potential to become the repository of digital patients, avatars, names that we like, or digital twins of humans that can be used by AI to perform the simulation of disease development and progression or simulate therapies. This is what we are, of course, looking for. Dose optimization, the EuroSafe imaging campaign launched by the ESR aims to raise awareness of the radiological community to dose optimization, reducing the biological risk of radiation exposure. What we can expect from AI? AI can be an optimized tool to assist the technologists and the radiologists in choosing the personalized patient's protocol, tracking the patient dose parameters, providing an estimate of the radiation risk associated with cumulative dose and the patient's acceptability. Structure reporting. In 2015, ESR joined the RSNA Structure Reporting Initiative to promote the adoption of structure reporting by the ESR radiological community. Through its potential, AI can aid the reporting workflow and help the link between words, images, quantitative data, and finally suggest the most probable diagnosis. One reflection about common data elements, which define the attributes and allowable values of a unit of information in structure reporting. This is a new initiative of RSNA that we have to join. CDA can be the vocabulary of AI to build a patient-specific structure report. The appropriateness, of course, ESR has implemented the iGuide, a clinical decision support system that assists referring physicians to choose the most appropriate imaging procedure on the basis of the level of evidence for appropriateness and the level of emergency. AI can impact on the daily workflow by filtering exam priority on the basis of appropriateness criteria. AI coupled with CDS can improve the decision process and thereby optimize clinical and radiological workflow. The article also refers to what are the obstacles to the implementation of artificial intelligence in radiology, and in particular to regulatory issues that have been mentioned by Adrian before, of its implementation with particular reference is made to the three laws of robotics. We like to play a game with these three laws of robotics. You know the three laws of robotics. A robot may not injure a human being or through inaction allow a human being to come to harm. First law. The second law is a robot must obey the orders given it by human beings, except where such orders would conflict with the first law. The third, a robot must protect its own existence as long as such protection does not conflict with the first or second law. So we play a game with the first law. A robot may not injure a human being. A tool, AI tool, should reach the best achievable diagnosis to improve patient health care. But AI failure or inaction should be taken into account, and this could bring a damage to the patient. So the first law suggests also that AI should be always supervised by a radiologist. And the Hinton statement that people should stop training radiologists within 5 years, deep learning is going to do better than radiologists, is in the opposite direction, obviously, in the opposite direction. A robot must obey the order given by human beings, the second law. The second law suggests that AI should be always supervised by a radiologist. Who is going to take responsibility? Here an example of a study recently published with the authors find that AI outperformed radiologists in detecting and characterize lung nodules. So at the end, once you have results of AI, do you discharge the results? You disregard the results? You cannot. So there is a problem in responsibility. Third law, the third law is presumably best applied to the fact that AI software may have a term once it becomes obsolete. We have to consider the obsolescence of our technology. This can be a risk factor for the final diagnosis and treatment of the patient. Imaging is rapidly evolving, so that the training of a software with specific imaging data can be insufficient once a new development of the modality. Introduced in the clinical practice. So in conclusion, the challenge is the change of the rules in the radiological profession, where radiologists must be prepared to use AI in radiology workflow to be confident that with it and capable to control it. These goals can be only achievable if new challenges is embraced and guided by radiologists. Radiologists must be responsive to change and do not feel like the coyote. So I conclude with two slides. The last two slides say that if machine will approach human intelligence, which is unbelievable, there could be a risk to forget who is born first. Intelligence creates technology, and technology enhances intelligence. It is a never-ending story. In such case, the risk will be similar to the end of the film AI. I don't know how many of you have seen this film. So you remember the aliens speaking with the main actor, the machine, and say, David,